Okay, let's explain statement. So I'm given three sets or multi-sets of sticks. I'm given R pairs of red sticks and G pairs of green sticks and B pairs of blue sticks. So each pair have exactly the same length. Okay, and we want to form rectangles to maximize their area, but with the following rule. So we want to take a pair of sticks of one color, so we can take a pair of sticks of red color, and then another pair of a different color. So we can take a pair from red and pair from green, and then make rectangle from them. Okay, so this rectangle can be also square. Okay, rectangle is a square. So now we have a rectangle with four edges. Two of them, each two opposite of them have the same color. Okay, and then the area of it is of course. Um, so if I took R1, G1, so the area would be R1 times G1. Okay, so the length times width. So let's let's explain this better here. So basically, I'm given three arrays. Okay, G1. Let's call it R, G, B. Each array contains of some pairs of sticks. And they don't have to be the same size. Okay, so now we are given three arrays, and we want to form such rectangles to get the maximum area. So if, for example, I could take the pair R2 with the pair B3. Okay, so I'll take R2 with B3. Then, so if I took it, I remove it. And then the area of this rectangle would be R2 times B3, right? Because I have two pairs of the same, I have two sticks of the same size of R2, another two sticks of the same size of B3. Okay. So the edges of the rectangle will be R2, R2, B3, B3. This is the length and this is the width. Okay. So the area is clearly B3 times R2. Okay. So what I want to do is get as many sticks as possible to form the most area I can form with these sticks. Okay, so what's the maximum area you can achieve? So I'm just given these three arrays and I want to print the maximum area I could achieve with these arrays. Okay, with these numbers. So it's a good problem to think of. So I'll let you think for 1 minute or so. If you have any idea, tell me. Okay. There must be many ideas to this problem. So think about what maximizes the area of the rectangle most. Okay, I'll give you a hint. What if these values are sorted? Or does it matter? Does it matter if these values are sorted? So would it be optimal to take the smallest one with the smallest one, or the greatest one with the greatest one, or greatest to smallest, or what? Think about it. Okay, I'll get to the solution now. But first, everyone understood the statement? Is there anyone who doesn't understand what the problem needs? Okay, let's explain. So let's sort the values of R and G and B. Let's sort these values. So if I sorted these values, so that means I'm sorted in non-decreasing order. Okay, so R1 is more than or equal R2, smaller than or equal R3, G1 smaller than or equal G2, and so on. Okay, B1 smaller than or equal B2. So to make things easier, let's forget about one array now. Let's make this not here. So now we have only an easier version of this problem. What if we have only two arrays? I think you could get that without me telling you. What if I have two arrays and I sorted each of them? What should be the maximum value? And I could only take one element from there multiplied by another element from there. So how could I achieve this maximum value? What element with which element? Can anybody tell me?
First
Show.
element from both
Sorry, what do you
will
say?
give the max. So first element from both the R and G will give the maximum because we already sorted, right?
So you're saying if it's sorted, so getting the smallest with the smallest until greatest with the greatest?
Yeah.
So
No, assuming that the sorting is in reverse order, that is descending.
yes. So what did you
So
say again? Uh, so here I have two arrays. So is it better to do 2 times 2, 2 times 3, or reverse, or what?
Basically, 3 times 4 would give us maximum.
Okay, 3 times 4 and
yeah,
2
that's
times
correct.
3 and 2 times 2. Okay, but do you know why? Why that?
Yeah, like the area is length time breadth. If the length is maximum and breadth is maximum, we will get the maximum area.
Mm, okay, that's intuitive, but I'm gonna make a short proof here to just make you all sure that this is the optimal way, because so many things look obvious, but they might be wrong. Okay, so if we didn't prove this, it might be wrong. So first, let's take only two elements and let's abstract them. So let's call them AB and XY. And we know that A is more than or equals to B and X is more than or equals to Y. So we want to prove that B times Y plus A times X, which is greater times greater plus smaller times smaller, is greater than. So we want to prove that this value is greater than taking smallest with greatest and greatest with smallest. So I want to prove that this is greater than A times Y plus B times X. Let's do this times things. Okay, that's better. So we want to prove this. How could we prove this? Actually, if we got the value of the left side and subtracted by the value of the right side, so if left minus right is greater than 0, then for sure this is the greatest value, right? So I'll just subtract subtract right from left, okay, and then I'll distribute the minus here, and then I'll want to reorder them. So I'll get by beside ay to get the y beside each other, okay? So by minus ay plus ax minus bx. So here I have y's and x's, and the next step would be taking y common factor and x as common factor, okay? So let's take y common factor and then make b minus a plus x common factor and this, and then a minus b. Okay. Okay. Then the next step would be so extracting. So I want to extract. So observe that b minus a is the negative of a minus b, right? So I want to extract a negative from this bracket from a minus b just to make it b minus a. So if I extracted negative here, so I'll turn this positive to negative, and then reverse the sign of everything inside this bracket. Okay, so make this negative and make this positive. So this is b minus a, right? Let's make it again. So b minus a. So now we have yb minus a minus x times b minus a, and we have the same bracket here. So let's again take a common factor of it. So b minus a, and then multiplied by y minus x. So that's it. So we know that b is greater than or equals to a, right? And y is greater than or equals to x. So now it's clear that this value is greater than 0, okay? And you might tell me that this could be 0, but it could be 0 only if a equals to b or x equals to y, and it won't matter this way, okay? So if this is 0, it will also be the maximum possible, so we cannot get greater than this, okay? So this is the proof. If we have two elements, that it's always optimal to get the biggest to the biggest and smallest to the smallest, okay? And we can, of course, generalize this to more elements, okay? Okay. So now that we have two arrays, and you all know that the best thing to do here is getting the smallest with the smallest and greatest with the greatest. So what about three arrays now? What should we do with these three arrays? Anyone talk if you have an idea here? It's fairly similar idea or the same idea.
So we need to pick up the two highest from.
Okay, so it will always be optimal to get the greatest values with each other, right? So let's reverse these arrays, reverse sorting this array. So make R1 greater than or equals to R2, greater than or equals to R2 to R3, and so on. So now we are saying that it's optimal to take the first elements. So I could take R1 with B1, or R1 with G1, or B1 with G1. So there are many possibilities, right? But how to determine which two pairs to get? So we have three pairs, right? So let's get only the first, for the first index, we have three pairs. We could get R1 times G1, or R1 times B1, or G1 times B1. We have three possibilities. And we could also, so in the problem, we could also forget about any element. Okay. So there are many possibilities now. So that suggests
Basically, we can take it a step further and further sort R1, G1, B1, and then take the largest of those as the product.
So sort these three arrays together. That's what you're saying?
No, like we have already done that, and like we have the largest element at the beginning of each array, RGB. And what I'm suggesting here is like further take like in this sorted array R1, G1, and B1. Our contender is among these three values. Let's sort these three value and take the largest of those two.
Okay, so try these three and then get the largest of these three pairs, right? That's what you're saying.
Yeah.
Okay. So this is a greedy approach where we want to get the best value at each step. So so what I said about this approach is it's the same as sorting all these three arrays together. So putting R beside G beside B, and then sorting the three of them together. Okay, so we'll end up with something like this. we'll end up with a mixed array, and we might have something like this.
Okay,
So
we slightly deviated from what I meant, but this is also a good thing. We can take 3 pointers pointing to 3 distinct type of basically, um yeah, pointing
oh,
to different kind of colors and like take the maximum of those.
okay, so it's again the same greedy approach. So getting the maximum value for each pair we are at. Okay, so to make this approach look easier, we just sorted these three arrays together. So it's the same. It will get us to the same value you're to the same approach you're saying. So sort these three arrays together, and we'll have some mixed items here. So we could have R1, B2, and so on, but we are sorting it descendingly. So R1 is clearly the biggest element here, and then B2, and then R2, and so on, and then G2, G3, so on. So what you're saying in your approach now is at each step we're getting the maximum pair. So I'm checking. So at the first step, I'll get R1 with B2, and then delete them.
Yeah,
Okay.
exactly.
Okay. And at the next step, I'll get R2 with G1,
Hmm.
and so on. R3 with G3, and then G3. I cannot take it with G4 because they are at the same array. So I'll take
But
this
B1.
G3. Yes, with B1. Okay.
Basically, that's
So
why we are
that's
using 3 pointers so that like 3 distinct colors are pointed to
yep.
at each step.
Okay. Yes, I got you. But let me tell you that this approach will fail and it will get a wrong answer. But why? So let's take an example of three arrays. So let's say, for example, 2, 3, 4, or yes, 2, 3, 3, and here 4, and here 4. So what will happen if we, so these are the three arrays, okay? So R, G, B. So this is one element, three element, and let's sort them. Sorry, 3, 2, 2. But now in this approach, we are sorting all of them together, right? So we'll get 4, with 3, with 2, with 2. So at first, so regarding this approach, at first we will only get 4 times 4, right? Because they are at different arrays. So the score will only be 16. And we cannot add more values because after deleting these two fours, we cannot take any two values from the same array, right? So the value now is 16. Did you get that? So the value to these three arrays is 16. But actually, this is not the optimal way. So the optimal way is getting 4 times 3. Oh, okay, let's make this 3, sorry. So again, after sorting all of them, we will the greedy approach will take
Okay, got it.
okay, so it will take 4 with 4, which will be 16. But actually, the maximum score will be 4 times 3 plus 4 times 3, okay, which will be equal to 24. So it's clear that this is bigger than this. So as I said before, so while we have so many possibilities, so that actually suggests DP approach. So it will be so I'll borrow the idea you suggest here, which are 3 pointers. So it will be the same thing but with DP. So we'll actually put 3 pointers, I, J, and K. So we'll have I, J, and K, and each of them is pointing to to the last biggest value we've taken. Okay, so at first I, J, and K will be equal to 0, 0, 0. And then we'll try every pair, and then this will be a straight DP. We'll try every pair and then go to the next step. So let's look how could we do that. So we'll have a function called solve, and we'll have 3 pointers in it. I, J, K. Okay. So at each step, so ijk means that we are now standing at element I from the first array, and then j from the second array, and then k from the third array, and we have not yet taken any value starting from I until the end of the array, and starting from j until the end, and k until the end. So now we have three values, and we want to try all these pairs. Okay, so we'll just try all these pairs. Okay, let's now again forget about the base case, and then we'll have three pairs, either I with j, or I with k, or j with k, right? So let's try them. Let's have the arrays here first. Int a size is 15. See if int a. So all the possibilities would be, so let's make int result equals to 0. So result will be equal. So first, we want to check, if we want to check the pair I with j, we want to first check if I and j are within the bounds of a and b. Okay, so let's have three values n, m, and l, which corresponds to the size of these three arrays respectively. So to take the value of this pair I and j, first let's see if I is more than n and j is smaller than m, then result will be equals to max result, or a of I multiplied by b of j. Okay, but then if I took the value of this pair, so if I took I and j, then I'll go to the next, then I'll go to solve, but with I plus 1 and j plus 1, because I've taken I and j. Okay, so I plus 1, j plus 1, and the same k. And I repeat this 3 times, but with the other pairs. Okay, so if I is more than n again, and k smaller than l, then result will be equals to max result, and solve I plus 1 j. I forgot to add the value of I multiplied c of k. Okay, the last step, let's just copy paste. So if j is more than m and k is more than l, then the result equals to max result b of j multiplied by c of k plus solve I j plus 1 k plus 1. So that's it. We're getting the maximum of these three pairs and then going to the next step. Okay, but what's the base case here? So the base case is actually, we could put a base case, but provided that we are putting if here and there and initializing result with 0. So if I'm completely out of bounds, so if I have no pair in bounds, so I'll just return 0. So I don't have to put an additional base case here. No, not return 0 result. So if I didn't get to anything here, the result will be 0. So I'll just return it. That's it. Let's make a memo array. Okay. So let's make result j of k. And if result equals to -1, then make result equals to 0, and then compute that. So that's it. That's the function to compute the answer. Did you all get it? Is there anything you don't understand it? Okay. So now let's take the input. The input will be taking NML and then taking the values of these three arrays. Can you excuse me 10 seconds? I'll come to you. Sorry for that. Okay. So now I'm taking the values of A. So now I took the values of the three arrays and then I'll just print solve 0, 0, 0. That's it. Let's try that. Must have some error here. So I should initialize memo with -1, of course. Forgot that. Okay, 20. $99. So there is a problem here. Oh, I didn't sort it, the values. So I should sort A, B, and C in descending order. Right. So sort A plus N in descending order. So that should be it. Okay. So any questions in this problem before I submit? Any part you don't understand? Okay, let's submit. There should be a bug here. So, no, no. So at this line, there could be out of bounds here. So yes, so I should increase one to the size of each array. But actually, let's not increase it in the memo. Okay, accepted. Let's move on to the next problem. So this is another interesting, good problem. I sent it in the chat. Take 3 minutes